Hello friends, thank you for your time to watch my video. To continue our video, in this video we talk about fundamental and derived units. I have already described, explained the story of fundamental SI units and derived units. Now, we will do a practice to solve some problems related to fundamentals and derived units. Thank you so much also friends for you to support my YouTube channel. If you need or if you want to get any update from me, you can click down notification. Question number 1. A cylindrical tube rolling down a slope of inclination theta moves a distance L in time. The equation relating these quantities is L brackets 3 plus a squared divided by p close brackets equals to q2 square sin theta, where a is the internal radius of the tube, p and q are constants. Which line gives the correct units for p and q? Friends, if you want to solve this problem, you have to understand about the terminology, or you can also take a note the terminology used in this equation. For example, distance L, the internal radius A, time t, the inclination theta, q and p are constants. Now, let's try to write down the units of each term. Inclination, the unit is in degrees. Degrees is not in SI units, so then we can ignore it. Distance L, the unit of distance is in meters. Time t, the unit for time t is in seconds, and then internal radius, its units is in meters. P and Q are constant, so that is why we need to find the units of P and Q. Now, for L is the distance. The unit is in meters. So we can copy everything into this equation, I mean the units. So then, meters, brackets, 3 plus a square, the unit for the internal radius is meter, so means here is meter square, divided by p close brackets equals to q s square sin theta. Now, so how to find the unit of q or the unit of p? That is why I put let the unit for p is meter square. So then I can input the unit for p in this equation. So m brackets 3 plus m square over m square equals to q s square sin theta, no unit. So then m square divided by m square is 1. 1 plus 3 equals to 4. So 4 is a number. So there is no unit. So we can ignore it. So m equals to q s square. And q equals to m s to the power of -2. So now the unit for P is meter square and the unit for Q is meter second minus 2. So the answer is B. Continue to answer question number 2. What is equivalent to the unit of electric field strength? Friends, if you want to solve this problem, you have to try to write down any formula about electric field strength. So I have some formula here. So the electric field strength is E. We can put E equals to force divided by the electric charge. And then the second one is E equals to delta potential difference over distance. So what do you think about this? I have two formulas about the electric field strength. Now, let's try to modify these equations. Now we know the force formula is equals to mass times acceleration. And Q is equals to the electric charge is I divided by time. This is electrical charge or electric charge. Or sometimes we can say the electric current. And then we also can modify the potential difference of guys. So delta V equals to energy, or we can say work done divided by distance. Not distance now. Divided by Q. Or we can say W over Q. Now, if you want to substitute delta V formula to the electric field strength formula, so we will get the third equations for E equals to work done over Q over D. So work done over D times Q. We also can modify for delta V equals to the electric current times resistance. But from the option, there is no resistance unit. All right, let's see. We'll try to solve one by one. We want to find the equivalent electric field strength. Yeah, the equivalent to the unit of the electric field strength. Let's continue for E. For the first formula, E equals to force divided by Q. So force is mass times acceleration. So force divided by Q. Now, what is force? What is the unit of force? It's in Newton. And then divided by Q is in Coulomb. So then, Newton, Coulomb minus 1. Do you have Coulomb minus 1? No. So there is no Coulomb minus 1 in the option. So now, let's try to find F over Q. What is F? Mass times acceleration. So mass times acceleration. Over Q. So what is the unit for mass? Kilogram, meter, second minus 2 over coulomb. So then kilogram, meter, second minus 2, coulomb minus 1. So there is no equivalent unit of the electric field strength in the option. So what else? We can use this formula again. So then E equals to W over dq. So then what is the unit for W or work done? Is joule, and then this is over meter C, and then joule meter minus 1 C minus 1. So this is the equivalent unit for the electric field strength. But there is no option. Yeah, there is no answer in the option. Now, let's try to modify again. So we have force divided by Q, so F divided by Q. We will try to modify Q equals to I over T. So then F over I over over time. And then I can replace Ft divided by I. The unit for F is Newton. Second, over the unit for the electric current is ampere. So then Newton, second, ampere to the power of -1. So we get the answer. The answer is Bravo. Next questions, which row shows an SI-based quantity with its correct unit? We know there are 7 SI quantities. Now we can see the option. Charge, the unit is in coulomb, current ampere, potential difference for temperature degree Celsius. Of course, we can also answer these questions. Charge is not SI base quantity. Current, yes. Potential difference, no. The temperature, yes. So there are 2 options, B and D. Let's see the unit. So current is ampere and temperature in degrees Celsius. So option D is wrong because unit for the temperature is in Kelvin. So the best answer is Bravo. Next question is the drag coefficient CD is a number with no units. It is used to compare the drag on different cars at different speeds. It is given by the equation CD equals to F divided by rho V to the power N A, where F is a drag force on the car, rho is the density of the air, A is the cross-sectional area of the car, and V is the speed of the car. Now, what is the value of N? Let's try. Because from the questions, the drag coefficient CD is a number with no units. So then we can compare the units in the left-hand side to the units in the right-hand side. Let's try to modify. I cross multiply, so rho V to the power of N A CD equals to F. So if series has no unit, so we ignore this. And then the density is rho. So the unit for the density is equals to kilogram over cube meter. F is the drag force. So then F in SI unit is in kilogram meter second minus 2. So this one is come from mass times acceleration. So the unit for mass is in kilogram. The unit for the acceleration is meter second minus 2. For A, it's a cross-sectional area. The unit for the cross-sectional area is square meter. And then V is the speed of the car. The unit for the speed of the car is meter second minus 2. Now here, I can substitute all units of the quantities into the equations. So rho is a kilogram meter minus 3. V is in meter second minus 2 to the power of n. A is a cross-sectional area, is a meter square. CD has no units, we ignore that. 2 has no unit, we ignore it. F is kilogram meter second minus 2. Now we can simplify the units in the left-hand side. Kilogram meter minus 3 meter to the power of n s minus 2n meter square equals to kilogram meter second minus 2. We can simplify kilogram meter minus 3 plus 2 minus 1 plus n s minus 2n equals to kilogram meter second minus 2. Now, here we know m to the power of n, m to the power of negative 1 plus n equals m to the power of 1. So we can cross m. So then minus 1 plus n equals to 1. So then n equals to 2. So the option B is the correct answer. Option B is the correct answer. Next question is, the elastic potential energy E is given by E equals 0 square G square A L0 to the power 3. Rho is the density of the metal, G is the acceleration of the free fall, A is a cross-sectional area of the wire, C is a constant. Determine the SI base unit of C. All right, let's try to analyze one by one. So the elastic potential energy is E. Elastic potential energy has the same unit for another energy. So we know the formula for any energy. You can use the simple one. Energy can be work done, can be force times distance. So force is mass times acceleration times d. So we can input the units for the quantities: kilogram, meter, second minus 2 meter. Simplify: kilogram, meter square, second minus 2. So this is for the units of elastic potential energy. The units for the density is kilogram meter to the power of -3. The units for the acceleration due to gravity is meter second minus 2. The units for the cross-sectional area is meter square, and then C is a constant. We need to find the SI base units of C, so we can input all units into the equation. Now, for E is kilogram, meter square, second minus 2 equals C. The density is kilogram meter minus 3 square G meter S minus 2 square. A is M square. L to the power of 0. L0 to the power of 3 is meter cube. Right? Because this is the initial length. Now we can simplify the units in the right hand side. So kilogram meter square S minus 2 equals C kilogram square M minus 6 M square S minus 4 M power 5. So kilogram meter square S minus 2 equals C kilogram square M minus 6 plus 2 plus 5 M only S minus 4. So then C equals kilogram meter square second minus 2 over kilogram square meter second minus 4. We can simplify kilogram minus 1 M S square. So this is the answer for C. So C equals M kilogram minus 1 S square. All right. So that's some questions for us. And then I hope everyone can solve my questions here before we continue to the next topic. I will clear all drawings. Now, this is my questions for you guys. Try to find, try to practice. This is for you. What do you think? I'll give you 3 minutes, and then you can put the answer in And then also you can give the solution for me. In the comment column. And then also these questions. This is also all right. Thank you so much, everyone. Thank you, friends. I'm waiting for your answer. So we can answer, you can put your answer in the comment column. Bye-bye, everyone. Bye-bye again.